Alrighty, good morning everybody. This is Mr. Steele. I am not here, as you can probably figure out. I am at UC Davis all day and all day tomorrow and all day on Sunday for alumni course, so I'm not here today. But at the same time, that doesn't excuse you from needing to learn things. So we're going to go ahead and continue forward by adding something a little bit different here. So far this week, all we've done is work on rational expressions, like doing things like add, multiply, divide, stack them up, and then divide them, all that good stuff. Today we are going to take a step forward and actually solve equations that involve rational expressions. So like rational expressions except with an equal sign also. So this is note 71. If you haven't already seen that, I'm expecting that while I blabber here, you'll be writing stuff down and kind of getting everything set up in your notebooks. Probably already kind of knew that was coming. And of course the essential question basically says, how do we attack rational equations and what role do restrictions play? So really have a twofold goal today, is to try to figure out how we deal with rational expressions and then figure out what the heck these restrictions are. We're going to do it in reverse order. We're going to start with the restrictions part, but we will come back to we will go right to the solving rational equations part as well. So, and this is part of the reason why we didn't have a standard quiz. I wanted you guys to have time to get through as much of the homework as you can before the weekend. So, place where we want to start is, first of all, what do we mean by a rational equation? Pretty straightforward question to ask since we're talking about rational equations here. Basically, this, sorry, ugly lines, gotta get used to a new computer that I can't draw lines on. So this is a rational equation. What makes it an equation? It would be the equal sign. So we've got two rational expressions, we've got a fraction on the left side with something variable in the denominator, fraction on the right side, and they're set equal to each other, so we have some sort of equality. And we want to figure out, of course, what are the x values that make this true? So we'll get to that in a second. In fact, you might even be able to look at this equation and figure out what the x value is. Just thinking about it for a second, you can probably see that the answer is 1. But that's beside the point. What we want to do is we want to first start by figuring out kind of a weird question. We want to figure out what answers can we not get to this equation. What are the values that will never work? The impossible solutions that if we see it, we're just doing it wrong. So what we do, where we have to start, or what's going to kind of guide us towards this first idea, which is called a restriction, is this idea of finding answers that can't work. And the way we're going to tell that is by looking at the denominator of each equation. So as I look at the two denominators here, since the denominator is such a big, crucial part of dealing with rational things, looking at those two things, we have to check to see if there's any number that could ever make that denominator equal 0. So 0, nothing. Of course, why would that be bad? Well, we can't divide a number by 0. Punch in your calculator, 1 divided by 0, error, error. Please try a correct operation. It's not going to work. We know that. So in fact, we're going to first check to see what values make the denominators equal 0. So what we can think of is, for each of these guys, check to see, could 2 equal 0? For example, using the right denominator. Could 2 equal 0? Nope, it can't equal 0. 2 and 0 are different things. On the left side, though, could that denominator equal 0? And the answer is sure. If we got x equals negative 1 as an answer, that would not work, because we'd end up with 1 divided by 0 equals something. It can never divide by 0. There's no time that's okay. So in fact, what we find is a number here, negative 1, that can never be our solution, simply because it would make a denominator 0. Any work we did would be obsolete if we got negative 1, because we knew that couldn't work. So that guy has a special name. A value that does not work in the equation is given the name of restriction. So if you've ever been grounded, that's probably pretty much everyone here. Basically, you're restricted. Your privileges are restricted. You no longer can do those things. You're not allowed to do them. Same idea here. So we're looking for the values that we're not allowed to get. So a better definition, I was going to say more better, but that doesn't make any sense. Restriction is the following. Let's see if I can draw a straight line while you copy that definition down. Betting I can't. Until I get some help. Have a little help from your line rearranger. Okay, so there we go. So there's our definition that we're going to use. Our working definition for restrictions. Restrictions are impossible solutions. So I might even put these word solutions in quotation marks because they're not really solutions. They'd be extraneous. Impossible solutions that would make a denominator 0. So basically, in order to find a restriction, we check to see what makes the denominator 0. And then we can tell ourselves, hey, wait a second, no, we're not going to have that as an answer. So for example, in this particular problem, we would have the restriction, which you will be prompted for on your homework. There'll be a little line there, probably a straight line. And you'll say and write down what numbers can't work. So in this case, 2 never equals 0, so we're good. But on the left side, x equals -1 would make the left denominator 0. So for our restrictions, we write that x does not equal -1. And then in our mind, we think, well, it's because -1 would make the left denominator equal to 0. That's not a good thing. We don't want that. So basically, finding the restrictions is as simple as looking at the denominators and figuring out what makes each of them equal to 0. So before we even start solving, all we're doing is we're narrowing it down. We're looking at an equation, we're figuring out what answers we can't get, so that we're especially vigilant about looking for those particular answers. So before we go into a real example here, that's a bad word for it. So something you'll be asked to do on the homework, I think at the very beginning, is we'll ask you to just look for the restrictions, not actually solve the equation. So state the restrictions. So state the restrictions, and then I gotta give you a rational equation. I can't just expect you to do that off the top of your head. So we'll go with the harder of these two that I had here. And again, I'm writing all these things down kind of slowly so you have time to kind of catch up as you go. So here's a rational equation. What we want to know is what are the numbers that don't work. So we want to be able to say that the restrictions, the impossible solutions we aren't ever going to get, that will never work because they'll make things divided by 0. Like, what are those numbers? So you can almost prepare it every single time you see that line. You can start by writing x does not equals, because basically we're trying to find the numbers where x can't ever be equal to them. Okay, so looking over here, as I look at this thing, trying to decide what the restrictions are, just like I would in any solution, any problem, or sorry, any equation that we might run into, all I want to think about is probably what the factors are. Like, factor those denominators out so I can see what all the things that could ever be made equal to 0. So x squared minus 4, what does that factor to? X minus 2, x minus 2. Yeah, good job. That would work. Excuse me. And then 4x plus 8. I'm thinking we can do what kind of factoring strategy? GCF. Yeah, GCF sounds good. Like it. And then over here, yeah, we don't have to do anything. It's just x minus 2. So those are all our denominators. We're just looking at a nice little listing of all of those guys. And then our question to ourselves is, well, what makes those guys equal to 0? What would be the numbers that would make this so we were dividing by 0? Well, clearly we can see what they are. What makes this first factor equal to 0? That's going to be -2. What makes the second factor equal to 0? Gotta be interesting. Could I call on someone right now and would you answer the question? That'd be kind of interesting. Maybe I'll try it later. So what makes that guy equal to 0? Obviously that would be +2. On the second one, you might think that 4 has something to do with it, but 4 never equals 0. So in fact, we don't have any restriction from there. We do have a restriction from x plus 2. It's -2, but we already got that one. No need to copy it again. And then finally, x minus 2. Hey, we got that one already too. That would give us x equals 2. So in this case, we have two restrictions, and those two restrictions, that x does not equal -2 and does not equal +2, tell us what answers to be on the lookout for that would not actually work. They're potential extraneous solutions that might show up when we're solving, but are not actually solutions to the equation, because as we said, it makes the denominator 0, no divide by 0. As the old saying goes, only Chuck Norris can divide by 0. Are you Chuck Norris? I don't think so. So, moral of the story is you can't divide by 0, so check those denominators. So there we go. So that concludes the first portion of the lesson. So how do we find restrictions? We look at the denominator, make them equal to 0. Any questions? Gotcha. Hope you didn't raise your hand. Okay, so just a second ago we looked at restrictions. Now let's take a look at our first rational equation. So we're just going to kind of jump in head first on this guy. Now that we know how to narrow down our possible solutions to get rid of a couple that can't work, let's actually look at an equation. And I'm going to give you a plan here. I will say that the plan's going to seem a little bit long, and I think a lot of that's because I'm not here, so I'm just trying to be really careful and make sure I cover every possible contingency. My process is a little bit slow, but so I encourage you as you get more and more comfortable with it to experiment and see what kind of steps you can kind of slide through or what kinds of things are there. But I feel really confident that my process here, which is different than normal, is going to work pretty well for everybody. So let's start with our first rational equation. So our instructions will tell us that we've got a rational equation because it will say solve, and then it will give us the piece. So our first one that we're going to play with, 5 over x plus 2 plus 3 over x plus 4 equals 5 over x plus 4. So there is our first rational equation. So take a second to get that guy down, please. Okay, so you can tell it's a rational equation. There's an equal sign. Like, first thing to check off is like, check. We got an equal sign. We've also got some variable stuff in denominators, so definitely a rational thing, and it's an equation as well because of that equal sign. So, what are we going to do first? Well, steps 1 and 2 don't relate to the actual solving. They're just kind of things that we have to do before we do anything else. So, step 1, we are going to factor all the denominators. So just take care of all those denominators and pull out anything that you can. Any kind of factoring would work. You can use diamond factoring. You can use difference of squares. We'll see that a lot. You can also do some sort of complicated factoring. For the most part, you just got to factor them. So as I look at these guys, that's already factored. That's already factored. And oh, look, just for a change, that one's already factored too. So all 3 of our denominators are already taken care of fine. So once they're factored, we are able to do that thing that we just practiced. We're going to look and we're going to state the restrictions. So we're going to take care of and make sure we've accounted for any possibilities and problems that might come up. See if I can fit this all in. I did. Ha. State the restrictions. So looking at these guys, we've got to decide what would make these denominators equal to 0. Like, what could cause us problems if those answers popped out at the end? Well, first one. What makes that denominator equal to 0? Good. It is x equals 2. So right down here in our restrictions, we'll put x does not equal, because we're not allowed to get these numbers, and then like you all just said a second ago, 2. So there's 1. Let's look at the next denominator. What makes this one equal to 0? Yeah, that's right. It is negative 4. So negative 4 is our second one. So we've got a second restriction. We have 2 at least so far. And then finally, if we look at the third denominator, you might immediately yell out negative 4, which is true. Like, that is in fact our, it would be a restriction that comes from that denominator, but already saw that guy right over here, so yeah, it's already taken care of. So we don't have to write it again. We've already got it. Turns out there are exactly 2 restrictions. Can't see it right now, but I'm making a 2 with my fingers. So first 2 steps are kind of like pre-problem. We just kind of make sure all the denominators are set, and then we state all the restrictions. Once we have taken care of that first step, the next thing we're going to do is like the crux, like the most important step of the entire process. So let me write it out first, and then we'll do it. And it may sound more complicated than it actually is. And it's basically our way that we're going to get rid of the denominators and find a nice way to do it. So a fancy term in there, the LCM. Okay, so I'll give you a second to get that in there. And hopefully as you're doing it, as you're writing in those letters and etching out that LCM, hopefully as you do that, you're starting to think back in your mind what it means to be an LCM. Like, what is that? Because you've done it before. It's just been a while. So for me, because I want to be really clear here, I'm going to take my equation and write it down here a second time. You can just use the original one that you wrote down maybe. So whatever works. So when I say that, we're basically going to multiply the entire equation by the same thing. And it's going to be the LCM, the least common multiple of our denominators. So what I mean is I look at my denominators and I look to see what's down there. We want to multiply by the smallest number that we can of every factor that appears in a denominator. So the first thing I see is x minus 2. So we're going to multiply everything by x minus 2 because that's going to have to show up if we want all of the denominator pieces to be represented. Second thing I'm going to put in there is x plus 4 because I see an x plus 4 in a denominator, so that's going to be included as well. Then over here, if this had been another factor, we would have had to have multiplied by that whole thing too, but in fact it's not. This is x plus 4 again, which is the same thing as the previous one. So in fact we only need to include it one time, and voila, this guy is our LCM. Like, that's the LCM of the denominators. We've just multiplied by the smallest number of everything that's down there. And our idea is we're going to allow ourselves to cancel out some of the denominator. So if that step seemed pretty complicated, it is. It's by far the most complicated piece that we have to do here. So just be on the lookout for it. We'll practice it a bunch of times. No stress at all. So once we've got that piece there, again, it is a little bit trippy. It's a little different. What we're going to do is we're going to distribute that LCM in. We're going to distribute it into every single term of the equation. So both sides of the equal sign, everything. Everything's going to get a dose of, in this case, x minus 2, x plus 4. So we're going to ghetto sprinkler this thing in. So though it's not going to be pretty over here, we're going to go nuts with this thing. So we're going to multiply it into everything. So now this is the step where those of you that are work ethic challenged, you're going to like, I don't want to do that. Well, yeah, maybe you don't, but it's going to work. Like, I like my strategy. I feel pretty confident in it. So we're going to multiply it into everything. So we had 5 over x minus 2. When I multiply all that stuff in, 5, x minus 2, x plus 4. So I've literally taken it and I distributed it into the whole thing. I'm not multiplying anything together. I'm doing nothing with it. I'm just distributing it in. Same thing on the next one. So 3 over x plus 4. We're going to multiply in by x minus 2, x plus 4. And then finally on the other side, look very similar. It was 5 over x plus 4. We're going to distribute in x minus 2, x plus 4. So yes, right at this moment you are almost playing the role of a Xerox machine, albeit a very handsome, thoughtful, mathematically inclined Xerox machine, and you're copying down that LCM over and over again. So again, some of you guys are thinking, oh, I don't want to do that. That's fine. Like, that's fine. You don't want to do this. That's true. But this will actually help us a whole lot more on the next step. A lot more than some of the other like shortcut quote-unquote steps that people throw out there all the time. So our next step is to cancel and to do it in each term. So we're going to look at all 3 terms that we have there, and we're going to cancel anything that we can. Because what will happen is if we've done this correctly, we'll cancel stuff and we'll be left with no more denominators. Bye-bye, fractions. See you tomorrow. Well, actually, see you in another example. Beside the point. So we're going to cancel out anything we can. So looking at this first fraction, so looking at this left one, anything cancel. See anything that can cancel. Anything at all. Anything. Anybody. Come on. Anyone. No one? No one. Oh, yeah, you're right. There is something. Gone. Notice that our denominator is finished. It's gone. No more denominator. All we'll be left with on this term is 5 x plus 4. Okay, let's try it again. See if this pattern follows. So 3 x minus 2 x plus 4. Dun, 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 dun. Goodbye. We're gone with the x plus 4s. They're gone. All we're left with is 3 times x minus 2. And finally, the last guy, familiar foe. No more x plus 4. We're left with 5 x minus 2. So basically, by canceling in each term, we eliminate the denominators. There's no more denominator here. And if you're trying to think to yourself, you know, Mr. Steele, I don't think there's going to be room to do that. I already beat you to it. I spaced out the homework so much. There's so much space. As long as you don't write in size 72 font, like, you should be fine. So what we've done is we've multiplied by the LCM. That allowed us to then cancel out all our denominators individually and separately, of course, but to do so. So now we have an equation right here at the star that is prime for us to actually start working with. Like, at this point, we've eliminated the whole rational part. Like, you don't even have to think about it. So at this point, we are going to simplify whatever we have and solve whatever those leftovers are. So I'll say leftovers. So we'll solve whatever we're left with. So in this case, that's going to involve a little bit of distributing. So if you thought that first sprinkler was ghetto and broken, I've got news for you. We got a lot of them here. It's an epidemic. Got 5x plus 20 plus 3x minus 6. Again, all we're doing is we're trying to get ourselves in position to finally be able to find x. So 5x minus 10. And then we can solve the rest of this guy. Let's see here. So if I minus 5x from both sides, let's see. If I minus those guys, they'll zero out. We will get 20 minus 6 is 14 plus 3x equals negative 10. With a quick little swoop here, minus 14 from both sides. We're going to get 3x equals negative 24. And at this point, it's like, yeah, goodbye. We get x equals negative 8. It sure looks like we've got our solution. Yeah, feel accomplished. Okay, so first, before we finish this guy off, questions? Any questions? Okay, don't see any questions. So, what do we do to finish? Basically, all we have to do is one quick little tiny check. There's just one thing we need to do. We need to make sure the restrictions and the solution not the same. Like, they aren't allowed to be the same. So, if they are, that means that we found an answer that would just make a denominator 0. And that's not cool. Nobody wants to do that. So, for our final piece, step 7, we just have to make sure they don't match. God, this plan's actually fitting in just nicely. So all we do is we make sure that we didn't get a restriction with one of our solutions or with our solution. So looking at this guy, I simply have to ask myself, are those restrictions the same thing as negative 8? Are they the same? So is 2 the same thing as negative 8? No, 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 no. No, they're not. So that we're good there. And is negative 8 the same thing as negative 4? Well, they're related, but no, they're not the same. So since they're not the same, we get our one solution, x equals negative 8. So that is the number that makes this entire equation up here totally true. If we plug in negative 8, we would get a true equation. Pretty cool stuff. Like, pretty cool stuff. Actual coolness may vary. So there we go. So there's our process. It seems long. We're working really carefully here. But again, I'm not going to ask you to do 20 of these for homework. There's like 8. Maybe it's even 6. I don't remember exactly. Some small number. And it just gives you an opportunity to practice these things. And, I mean, really, the big step is this big guy up here. We're always going to have to be really careful multiplying by the LCM. So, okay. So we've seen it once. I know it's not enough. Let's go ahead and take a look at another example. Try to get you a little bit, maybe an easier one, just to kind of, hammer this process in. So let's do that. Okay, so here we go. We've got one example under our belt. Let's just take a step back. Let's look at a simple one just to make sure this plan all fits into place. And then we'll look at a harder one before give you one to try, and we make you homework time, or give you homework time. So let's take a look at this guy. Our second equation, a lot shorter, just fewer pieces to stare at. 4 over x minus 5 equals 11 x plus 1. Yep, there we go. So here's our second equation. So slightly different than the last one. The first one had 3 terms. This guy's only got 2 terms. So definitely something that benefits us a little bit. So we're going to have to look at this guy. We want to solve this equation. So let's see here. So looking at my steps, trying to go through and solve this guy, figure out what x's might work. The first thing that I noticed I'm supposed to do is factor all the denominators and state the restrictions. So looking at this guy, I see both denominators are already perfectly well factored, nothing to do with them. So we're done factoring. Instead, what we want to do is we want to figure out what makes them equal to 0. So let's see here. Let me call on somebody. This would be good. How about Evan? What's the first restriction? Good. Excellent. I'm assuming that you did it. Thank you, Evan. Thank you, Evan. X equals 5 cannot equal 5 because x equals 5 would make the first denominator equal to 0. And then how about we ask... Oh, it's hard to call on people when you can't actually see anybody. How about Alyssa? Alyssa, what would make this denominator equal to 0? Yep, exactly. Negative 1. So we've got 2 restrictions. X does not equal 5 because that would make the first denominator 0. And x does not equal negative 1 because that would make the second denominator 0. So, good deal, good deal. Thank you, Evan and Alyssa. If you weren't both here, that would be awkward. Hopefully you were. Okay, so we got that. Next, we're on to our second step here. So we've got to go through, we've got to multiply by the LCM to start clearing these denominator thingies. So, again, there are other ways to do this guy. I'm just going to kind of stay consistent, give you a method that works really well, and we can talk about other ones later. So I can clearly see what my LCM is going to be. We've got x minus 5, so I'm including x minus 5 right there. We've got x plus 1, so we've got x plus 1. That way all our denominators will clear once we actually multiply. So finding the LCM, not hard when you only have 2 pieces, so it's beneficial. It's ghetto sprinkler time. Let's multiply in this whole LCM. So we will get 4 over x minus 5. We're going to multiply in x minus 5, x plus 1. And on the second side, we'll have 11 over x plus 1. And it's going to be x minus 5, x plus 1 that goes in. So again, all we're doing is we're distributing it in just like we would a number, except we're multiplying it into everything. Like some of you might think of this as like the fraction busting step. We're preparing to fraction bust. Or we're showing why it works. Okay, so we distributed the LCM into everything. Time to cancel in every term. So we're looking at every term, trying to make sure that we cancel out and get rid of the denominator. So x minus 5 over x minus 5, that equals 1. X plus 1 over x plus 1, that also equals 1. So we are left with, as our equation, 4x plus 1 equals 11 x minus 5. So there is our equation. I don't know why I wrote over there. That was silly. So there is our new version of the equation, which I definitely like it a lot better than the last one. So there it is. So what we're going to do, let's simplify and solve. So we're getting back down to the stuff we did at the beginning of the year, just Algebra 1 concepts. 4x plus 4, 11x minus 55, as the cool people say. And then we got to solve this equation. So some integer work here, some negative stuff, some positive stuff. Got a little bit of everything. Going to subtract 4x. Going to add 55. Bam, 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 bam. So we'll get a 0. We'll get a 0. We're going to get 59 equals 7x. And if I divide by 7 to get x alone, that's a really long 7, but that's okay. We don't judge. X equals 59 over 7. So we apparently have our answer. The only thing that could stop us from being done, the only thing would be if that was the restriction. So 59 over 7, not the same thing as 5, not the same thing as negative 1. Therefore, we have solved this equation. So it's not a juicy, rewarding answer like negative 8 was on the first one, but hey, we found the answer. That's the number that we would have to plug in order to make this equation at the top true. So process, pretty clean, pretty simple. We only had 2 terms, so understandably easier. But again, we were able to make this work pretty nicely. Questions? Oh, I forgot I can't answer. So there we go. Well then, we've got pretty good work so far. One thing I want to do is I want to kind of do a problem that's a little more involved, a little bit more challenging than our first 2 examples here, just so you've seen a more comprehensive view of what kind of stuff you're going to run into. So I've got one more example before I give you a single try it, and we're almost done. Almost there. I know it's a Friday. I know it's been a long week. We can do this. So let's take a look at one more ejemplo. So I'm going to write this guy out. Again, there's nothing really on the surface that's going to be bad about this guy. It's just going to involve a little more attention all the way around. So let me find it. There we go. So I know it's not much of a vinculum right there, but it's there. So I'll play it safe. Okay, so there is our third and final example that we're going to do. And again, if you feel real comfortable with this, work ahead of me. Like, by all means, work ahead of me and see what you can do. We're going to play it safe, though, here and be real careful. Excuse me. Okay, so there's our equation. So up to this point, whenever we've done that first step, it's just been a formality. We've just been able to kind of skip through it because all the denominators were factored. But I'm thinking we're not going to have the same situation here. So what I'm going to do is I'm going to rewrite the problem one step down just so that I can have everything factored before I start thinking about restrictions. So the first guy, x over x minus 3, denominator is already factored, nothing to worry about. The second guy, this minus 24 over x squared minus 9, well, x squared minus 9 factors. We know what that factors to. What is it? Yeah, there we go. I got it. That's exactly right. X plus 3, x minus 3. So it's a difference of squares. It breaks up really nicely. You can imagine doing the little square roots and thinking about what the 2 factors are. There it goes. Final guy, yeah, he sits around. The one other thing I'm going to do here, just for simplicity, just because we're here, is that stupid minus sign. Ugh, minus signs. That minus sign, I'm going to make it plus a negative. So that'll just save us from having messy little minus signs hanging around all the time. So I'm just making that switch now. Is that okay? If anyone disagrees, say something right now. Gotcha. So there we go. There's our stuff. So we've factored all our denominators. We've got it now ready to state the restrictions. So pretty clear what two numbers are going to make this thing equal 0. We've got x minus 3 and x plus 3 littered throughout it. Our two restrictions will be plus or minus 3. So again, we have two restrictions. Plus or minus 3 are the only answers that will give us trouble. That we have to give ourselves pause when we're going through. So there it is. Everything's ready to go. It's now time to multiply the whole thing by the LCM. So although there are a whole bunch of factors hanging down there, really the LCM is really short. It's x minus 3, x plus 3. And if you're not sure where I'm getting that from, just take a look. X minus 3 shows up right here, and it also shows up right here. So if we multiply by it, we'll get rid of all of them. X plus 3 shows up on the far right, and also once in the middle. So we actually have taken care of everything with just two factors. So by factoring it all, we could quickly see that those were all we were going to need. Otherwise, we might be tempted to think that we needed to multiply by x squared minus 9. Okay, so here we go. So we're multiplying by the LCM. We got to distribute that stuff in. Let's distribute that puppy in. I actually enjoy doing this step. I like the distributing thing. Okay, so what do we get if we multiply that whole thing in? It's going to be messy. We're going to have x minus 3, x plus 3. Again, I'm thinking some of you are probably comfortable saving yourselves a step here. We'll have plus negative 24, x minus 3, x plus 3, all over x plus 3, x minus 3. Again, it's the longest step, and notice it's not taking forever. And what else are you going to do? Raise a hamster? Jeez, we can do this. 4 over x plus 3 is going to then be multiplied in by x minus 3, x plus 3. So we've gotten everything in there. All our pieces are in. We're distributed completely in. We're ready to do the actual canceling. We're ready to do the fun part. So imagine whatever epic music you go for. There we go. Done. Didn't even need the full song. So what does that leave us with? That leaves us with x plus 3 plus negative 24. Okay, that's kind of boring, but sure, we'll go with it. And then over on the far side, 4 x minus 3. Okay, so all the classic same steps that we've done before. One thing I'm going to change is I don't like that line. I want to go. Yeah, it's more fun to slash twice. Okay, so there's our stuff. Like, there's our equation. This is the guy that we need to simplify and play with. It's just going to be a little more involved than some of our other ones. So if I start looking at what I can do, got some distributing to do. Going to get x times x is x squared plus 3x minus 24 equals 4x minus 12. I'm going to need to move all this stuff to the same side. So the reason I know I need to do that is I've got a quadratic. I've got an x squared there. So I'm going to subtract 4x from both sides. You know, we have to do a little bit of work. That's reasonable. So I'm going to do those guys. I'll get a 0, a 0. Over here I'll have some work to do. Get x squared minus 1x minus 12 equals 0. So there is my equation. I got to figure out when this thing's equal to 0. Well, we can do that. This is just a diamond. And since it's just a equals 1, we can actually do this probably in our head. So what two numbers multiply to negative 12 add up to negative 1? You tell me. I like it. Yeah, I'm hearing it. Yeah, x minus 4, x plus 3. So those two guys equal 0. And that means dun, 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 dun. We get as our two solutions. Two solutions. This is an awesome equation. What a great finish to our Friday. We get 4 and negative 3, and we are totally happy. Those are great answers. We are done with this problem. We're feeling good. Only one problem. What's the problem? Any problem? Color overload? Yeah, it could be color overload. Anyone see anything? Anyone see anything? Something kind of fishy here. You know, something kind of fishy. By the way, if your goldfish looks that color, don't eat it. So, what's fishy? Yeah, the problem is one of our answers is actually a restriction. One of those answers happens to be in the denominator. Unfortunately, that negative 3, because it's one of our restrictions, means it can't possibly be an answer. So it's crossed off. It becomes an extraneous answer because negative 3 is a restriction. So basically, as soon as we see that match, whoa, no, that guy doesn't count as an answer. In fact, our only solution is going to be x equals 4. And our reason for that is negative 3 is extraneous. So you might mark that down. If not, if you crossed it out and had it in your work, that's perfectly fine. So, in fact, we can get extraneous answers here, and we happen to run into one just because when we factored, we ended up with a funky answer like that guy. Okay, so again, we finally got to see it. We finally saw why the restrictions matter, is we almost walked into the trap of having something that makes our equation divide by 0. No such trap. Got it. Okay, questions? Did you raise your hand? Hopefully not. Okay, so there we go. There's all my input for you. So there is our equation. We've solved 3 of these guys. It's now your turn to give it a shot. Okay, fine. Here we go. Last thing we're going to do today is a quick little try it. I want you to try one of these problems and make sure that you're in good shape for everything before I give you the homework, before I ask Mr. Roman to give you the homework. So our last equation here, which I will ask you to try on your own with the video paused, and then we'll come back together and check it, since you can't bring it up to me since I am in Davis right now. Let's give you this guy. Okay, let's make this our equation. So I want you to try to solve the equation 3x over x minus 2 equals 5/3 plus 10 over x minus 2. So I want you to do everything here. Check for the restrictions, do the whole process, the whole 9 yards. And then from there, we'll come back together and check it. So Ms. Roman, if you could pause the video right about now, we'll come back in just a second. So please pause now. Okay, I'm counting on the fact that the video is paused, and now I'm back to actually do the problem for you. So let's make sure we're in the same spot. So I'll go through it pretty quickly. I'm going to work at like the normal quick pace. So all my denominators are factored. So the first thing I see is that all I need to look at are the restrictions. So I only see one restriction. X cannot be equal to positive 2. That 3, not going to affect it, because 3 never equals 0. So taken care of, next thing I do is multiply by the LCM. So I'm going to multiply this whole thing, which I can cheat by stealing this guy. I'm going to multiply this whole thing. Let's see, what color do I need to do with purple? So multiply it with purple. Jeez, I'm rushing myself. Multiply everything by 3x minus 2. That's going to be my LCM of everything here. If I distribute it in, I'll get 3x times 3, x minus 2 over x minus 2 equals 5 times 3, x minus 2 all over 3 plus 10 over x minus 2 times 3, x minus 2. Okay, so everything's multiplied in. Now my canceling. So I forgot to do that in Panko. Well, I'll fix it. Jeez. This pace is relentless. So much pressure. There. Okay. So everything from being distributed, start canceling. Bam. 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 Let's see. So what does that give me? I get 3x times 3, which is 9x, plus 5 times x minus 2. I'll have to deal with that in a second. Plus 30. Oh, sorry, I missed one, didn't I? It wasn't supposed to be a plus sign here. It was an equal sign. So there we go. Everything's kind of set up. So now if I just kind of simplify my equation, which is supposed to be in green. Yeah, there we go. Okay, it's supposed to be in green. So 9x equals 5x minus 10 plus 30. So I'll start simplifying and pulling stuff over. So I'll subtract 5x, get 4x equals negative 10 plus 30 is 20. Divide by 4. Divide by 4. It looks like our answer is going to be 17. No, just kidding. Obviously it's not. Answer should be 5, as long as 5 isn't a restriction. Is it a restriction all at once? Is it a restriction? 1, 2, 3. No, yes, no. No, it's not. 5 and 2, not the same thing. In fact, we found our solution. X equals 5. So if we want to know the number that makes this whole equation work out, it would be 5. So with that said, that covers everything that I got for the lesson. I mean, I'm pretty much through. So your job for the remainder of the period is to work on that homework, try to get through as much of it as you can so that you can be done with it as soon as possible, because that way you don't have anything on the weekend. Don't want you to have anything on the weekend. Either way, though, like if you have any questions, you could rewind the video. It'll be posted on YouTube, so you're welcome to go look at it there as well. It's just on youtube.com/Mr. Mike J. Steele, all one word. You could do that. You could talk to some of the people in class. I know there's some people that are really good at this stuff. Otherwise, yeah, work on the homework. So thanks for watching. Thanks for kind of following through. And I'm not supposed to finish. So this is Mr. Steele, and I am signing off for the night, or from your perspective, the day. So enjoy your weekend, enjoy finishing the lesson, and see you on Monday.